Okay, here we go. We're gonna do Unit 4, Lesson 4, which is on page 145. And then I'm also gonna do Lesson 5. So this is gonna be a combo video, Lesson 4, Lesson 5. So Lesson 4 is called Ratios in Right Triangles. And it says let's investigate ratios in the side lengths of right triangles. So you got these two right triangles. They each have this 20-degree angle right here. I'm just gonna color it in green. Now the question asks you, consider A over C and B over D. Or in other words, consider A divided by C and B divided by D. Which is greater, or are they equal? Explain how you know. So, the first thing I'm gonna note is you've got a 90-degree angle. And then you have the 20-degree angle. So you've got a 90 and a 20. That's two pairs of congruent angles. So what you're gonna use is the angle triangle similarity theorem. Which we learned in Unit 3. So Unit 3, we learned about the angle triangle similarity theorem. So what does that state? It says that if you have two pairs of congruent angles, so like for instance the 90 and the 20, then these two triangles are similar. So those two triangles are similar because you have two pairs of congruent angles, the 90 and the 20, meaning that these two triangles are the same shape. It also means that this angle is going to be congruent to this. And it also means that all the sides are in the same proportion. And that proportion can be represented by a scale factor. This is all from Unit 3. So basically, A times the scale factor will equal B. C times the scale factor will equal D. So this triangle is a little bit bigger than this, but it's the same shape, and every single side is dilated by the same scale factor. So what we typically have done in the past is we have said that we started comparing corresponding sides. So this A and this B. So in the past, we've been going A over B equals C over D. Now, when you get a fraction or a ratio equaling another fraction, then you can cross multiply. It's got to have an equal sign in between them. And then you'll find that A times D, AD, will equal B times C. Now, I have taught you that comparing corresponding sides of two similar triangles, you can go A over B equals C over D, right? So you can compare the corresponding sides of the triangles. You can also compare A over C to B over D, and I'll show you why. Just remember that AD equals BC because we cross multiplied. Now let's see if we go comparing this side to this side in the same triangle. So say you had A over C equaling B over D. And then say we cross multiply again. So see how this one was A over B equals C over D, and this one was A over C equals B over D? In both instances, A times D equals B times C. See these? So that's one way to kind of prove that in similar triangles, you can either compare the corresponding sides or similar sides, or you can compare two sides of the same triangle to two sides of the other. So in both instances, AD equals BC, AD equals BC. And the question is, which is greater, or are they equal? They are equal. Explain how you know. I know because the triangles are similar. How do you know that? Angle, angle, triangle, similarity theorem. And in similar triangles, side ratios remain the same. Side ratios remain the same. The sides don't remain the same. They grow a little bit, A to B, C to D, but the ratios remain the same. A ratio is a fraction. Okay, so that was 4.1. I'm gonna skip 4.2. I'm gonna skip 4.3 too. 4.2, we used a software called GeoGebra for this one. It was a pretty cool lesson, but essentially what you're gonna need to know is that if you have a 90-degree angle and the same acute angle, the side ratios will stay the same. So A over C will equal B over D, no matter how big this gets. Now, let's go to the lesson summary. So the lesson 4 summary says that all right triangles that contain the same acute angles are similar to each other. All right, so right triangle, right triangle, right triangle. They all have this 25 here. You'll notice that this one is going to be 65 because of the triangle sum theorem. Because 90 plus 25 plus this blue will always equal 180. Now if you just subtract 90 to both sides, you're gonna get 25 plus this blue angle equals 90. Now you subtract 25 to both sides, so that blue angle will equal 65 degrees. So you now know that right triangles with the same acute angles, red and blue, red and blue, red and blue, they're going to be similar to each other. What does similarity mean? It means the same shape. All corresponding angles congruent. Now, it also states that the ratios of corresponding side lengths are equal for any of these triangles. There is your angle-angle triangle similarity theorem, huge, from Unit 3. So these triangles are all similar by the angle-angle triangle similarity theorem. Now focusing on these red angles, we need to work on identifying opposite, hypotenuse, and adjacent legs. Now let's look at opposite. So the opposite leg from this red angle on this bigger right triangle is 4.2. It's across the way. It doesn't actually touch this side right here. This side does not touch this angle. So from the perspective of the 25, 4.2 is opposite, 3.0 is opposite, 2.5 is opposite. So we're done with opposite. What does opposite mean? It means does not touch the angle. So opposite leg does not touch the angle that we're looking at. So AC, FD, and L do not touch this red angle. Okay, hypotenuse is really, really easy. It's the longest leg. So 4.2, 9.1, 10.0. 10.0 is the longest. That's the hypotenuse. It sounds exactly how it's spelled. Hypotenuse. All right, so this, and this are all the hypotenuse. What is the hypotenuse? It's the longest leg of a right triangle. It's the longest leg of a right triangle. Okay, and then adjacent. Now we're still looking from the perspective of the 25-degree angle. So from the perspective of the 25-degree angle, there's two legs that create the angle. There and there. There and there. These two legs create this angle, right? One of the legs is the hypotenuse, the longest leg. The other leg that creates that angle is known as the adjacent side. Adjacent means touches. Now, the USA, north of the USA, Canada. South of the USA, Mexico. They share borders. USA and Mexico. Or sorry, USA and Mexico share this border. USA and Canada share this border. So if I were to ask you which two countries are adjacent to the USA, you would say Canada and Mexico. So adjacent means touches or borders. So these are all known as ADJ, which is short for adjacent. So we're looking from, again, the 25-degree red angle. Opposite leg does not touch the angle. Adjacent leg does. And then the hypotenuse is the longest leg. Now, focusing on the 25-degree angles, you see that all three have adjacent leg to hypotenuse ratios of approximately 0.91. What the heck does that mean? So that means that adjacent 9.1 in this one, adjacent, divided by 10 equals 0.91. Let's look at this one. That means that adjacent, so remember it's adjacent over hypo, adjacent over hypotenuse. Let's look at the second one. 6.5 over 7.1. Let's see if that equals 0.91. 6.5 divided by 7.1. 0.91. Cool. 5.4 adjacent divided by hypotenuse divided by 5.9. 5.4 divided by 5.9. 0.91. So that's what they're saying. So the ratios are the same. Similar to this one. Ratios are the same. Okay, so because all right triangles with the same acute angle measures have the same ratios, fractions. So another word for a ratio is basically a fraction. That's how I always remembered it. We can look for patterns that'll help us solve problems. The right triangle table comes from measuring and finding ratios in several right triangles with different angle measures. So they found long time ago that no matter how big the size of the right triangle, if the angles, the acute angles are the same, the ratios are the same. So this happened every single time. So look at this triangle, got bigger, but all the ratios are the same, comparing the sides. Now you can compare any two sides. You can compare opposite over hypotenuse for all three, and you'll find the same decimal. So we get these decimals. Whoever discovered this is just probably blew their mind when they first discovered this. But for any angle measure, adjacent divided by hypotenuse is in this table. Opposite divided by hypotenuse is going to be found on that column. Opposite divided by adjacent will be in this column. Now, I'm going to go get the handout that you'll need. Here's your handout. So you've got all your angles listed. So 10, 20, 30, 40, 50, 60, 70, 80. Adjacent over hypotenuse is here. Opposite over hypotenuse, opposite over adjacent. Here's the fives. 25, 35, 45, 55, 65. You've got these tables ready to roll. These are set in stone. What does that mean? That means these values are never going to change. Okay, so let's get to the next part. Some ratios in this table are repeated. Notice that the rows for 25 and 65 have two of the same ratios. Okay, let's look. 0.906, 0.423, 0.466, okay? 65, 0.423, 0.906, 2.145, okay? These are different, but this matches this, and this matches this. That is interesting. Let's look at the 35 versus the 55. 0.819, 0.819, okay. 0.574, 0.574, strange. And then look at the 45, 0.707 and 0.707. Okay, so people discovered these things, and what they found was that complementary angles, so complementary angles add up to 90 degrees. So there's a lot of examples you could use. So what 10 plus what equals 90, 10 plus 80. 20 plus what equals 90, 20 plus 70. 30 plus what equals 90, 30 plus 60. These are sets of complementary angles. They're angles that add up to 90 degrees. They found that opposite over hypotenuse for 35 is the same as adjacent over hypotenuse for 55. 35 and 55 add up to 90. They found that adjacent over hypotenuse for 25 will equal opposite over hypotenuse for 65. So for complementary angles, these are switched. Why? Let me draw you a figure on the back of this. Here's a right angle right here. So there's a right triangle. On the first one, we're going to look from the green. Let's just call these both A, B, C. A, B, C. And then we'll just say X, Y, Z. X, Y, Z. Okay. We have two congruent right triangles. I want to look from angle C. On this one, And then I want to look from angle B on this one. All right. So from this angle C, the leg that does not touch angle C is the opposite leg. This is the hypotenuse, the longest leg. Now, if you don't have measurements, how do you know which one's the hypotenuse? It's always across from the 90. It never touches the 90-degree angle. It's opposite from the 90-degree angle. The hypotenuse is always across the way from the 90. That's the hypotenuse. All right, now from angle C, remember we're looking from angle C right here. The adjacent leg is right here. So, let's look at opposite over hypo. We're just gonna plug them in. Remember, angle C, opposite, X, hypotenuse, Z. Then let's look at adjacent over hypo. Adjacent, Y, hypo, Z. Okay. Now let's switch to the red angle over here. So we're looking at angle B. Imagine you're hanging out over here at angle B. Y is your opposite leg now. Why? Because it does not touch. This side does not touch angle B. So it's considered opposite. Z is still the hypotenuse because it's still the longest side of the right triangle across from the 90. X is adjacent. So this is the first one, this is the second one. First one we're looking from the green, second one we're looking from the red. So let's look at this one, opposite over hypo. But we're looking from the red. Opposite is Y. Hypotenuse is Z. Now let's look at adjacent over hypotenuse. X over Z. Adjacent, X, divided by hypotenuse, Z. Weird. This X over Z, Y over Z. Complementary angles. Why? The acute angles, the ones that are less than 90, in a right triangle will always add to 90. Anyway, that's a visual for you. Hopefully that didn't confuse you, and we're gonna get so much practice with all this. Okay, that was lesson 4. You need this table, and I'll make sure everybody has one. Okay, let's move on to lesson 5. All right. 5.1, launch pad. When a rocket is launched, so you got this rocket. So we're launching this rocket, right? Got this rocket that we're launching. It climbs 50 feet, so it goes up 50 feet for every 13 feet horizontally. So what that's stating is that let's go like this. For every 13 feet horizontally, this rocket climbs 50 feet vertically. That's what that is saying. So for every 13 this direction, it goes 50 this direction. Rocket launch. This is your rocket. Draw a diagram to represent the situation. So we'll just color this in red. So this is our rocket launch angle. So the rocket launch angle is here. Now you know the two sides, 13 and 50, this is a right triangle. So I'm going to show you that if you have a right triangle and you have the any two sides, you can solve for everything. So, rocket launch angle is right here, this red one. We have to estimate the rocket's launch angle. Gotta estimate it, okay? So, from this angle, the 50 is considered opposite. Why? Because it does not touch, this side does not touch this angle. So it's considered opposite. The 13 does, and you gotta ask yourself, is it the hypotenuse or adjacent? Well, it's adjacent. How do I know that? Because the hypotenuse is always across from the 90-degree angle. So this is always the hypotenuse. If you know the right angle, the hypotenuse is across the way. It doesn't touch the right angle. So 13 is known as the adjacent leg in this instance. So you're going to say that opposite over adjacent equals 50 over 13. Now, that's about 4 times as big. 50 is about 4 times as big as 13. But let's get an exact number. 50 divided by 13 equals 3.846153846. Okay, let's just go 3 decimal places. 8, 4, and since that's a 1, we keep it at 6. So 3.846. This equals opposite over adjacent. This is the magic number we need. Now, once you get this number for opposite over adjacent, you can then use your table. Now, this is opposite over adjacent. Opposite divided by adjacent. The number we're looking for is 3.846. That's the number we're looking for. So, what you do is you find the number in the table. Okay, that's not 3.846. That's not. Okay, it's in between these two. So 3.846 would fall in between one of these two numbers. If it was 2.747, you would know that the rocket launch angle was 70 degrees. If it was 5.671, you would know the rocket launch angle is 80 degrees. But it's 3.846, so it's not perfectly 70, it's not perfectly 80. But it is in between these two. So we got to decide where in between these two. And remember, it's just an estimate. To estimate means to come pretty close. So I know it's in between 70 and 80. I could just say it's 75 degrees and call it a day. And that would prove to me that you know how to use the table. But you would only get 3 out of 4 if you stopped here. Because we know that 3.846 is closer to one of these two numbers. Let's look at 2.7 and 5.7. Let's just look at these two and compare which one it's closer to. So 3.8 and 2.7, roughly. 3.8, 2.7 is about a difference of 1.1. 3.8 minus 2.7, 1.1. 3.8 minus 5.7 is 1.9. So it's a little bit closer to 70 than it is to 80. So a perfect answer would be an estimate. I mean, not a perfect answer, but the range of answers that would get 4 out of 4. I would accept 71, 72, 73, and 74. Because that would show me that you know how to use the table, but you also know that this is closer to 70 than it is to 80. So I'm gonna go with 73 degrees for my answer. It may be 1 or 2 degrees off, but this is how you estimate angles. And estimation is huge in geometry. All right, sketch a triangle with side lengths 7, 24, and 25. Now, you need a tool. Specifically, you need a ruler. All right, so we got to sketch a triangle with 7, 24, and 25. So, count them off. 1, 2, 3, 4, 5, 6, 7. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 2, 2, 3, 24 right there. Is that? Is that? What's that? 7, 24. This is 25. It's called a Pythagorean triple. Label the smallest angle A. Okay. Find 3 ratios of side lengths for angle A. Well, you got 7 over 25. You've got 7 over 24. And you've got 24 over 25. There's 3 ratios of side lengths. Opposite over hypotenuse. You got opposite over adjacent, and you've got adjacent over hypotenuse. Now you got to estimate the acute angles in this triangle. So let's look at opposite over hypo, which equals 7 over 25, which equals 0.28. Opposite over hypo, opposite divided by hypo right here, 0.28. Oh, it's in between these two. 0.28 is a little bit closer to 20 than it is to 10. So I'm going to say A is 16 degrees, which means this one would be 74 degrees. That's how you do it quickly. So 16 degrees and 74 degrees. How do I know 16 and 74 quickly? Well, they both add up to 90. All right, solve all the triangles. Here we go. And I gotta run. What is the length of segment AB? All right. So they give you the 20-degree angle. Let's identify things. So AB, does it touch the 20-degree angle? Yes. So this is opposite. This is hypotenuse. This is ADJ. So hypo, ADJ, this is opposite of the 20-degree angle. Now, we know from our table right here that adjacent over hypotenuse equals adjacent divided by hypotenuse equals 0.940. So you can just plug in what you know. So adjacent is AB. Hypotenuse is 8.5, and that equals 0.940. Now, put these over a 1. Cross multiply. AB times 1 is just AB. 0.94 times 8.5. 0.94 times 8.5 is 7.99. AB equals 7.99. That's it. Rewind if you need to. In a right triangle. I'm going to go quick on this one. So in a right triangle with one angle measuring 40. The leg opposite is 5. What is the length of the hypotenuse? All right. Opposite over hypo for 40 equals opposite over hypo for 40, 0.643. I just quickly use this table. 40 opposite over hypo, 0.643. Now you just plug them in. So op over hypotenuse is 5. Hypotenuse, we'll just call it x, equals 0.643. This is x. Throw that 1 over it, cross multiply. 5 equals x times 0.643. Divide by 0.643 to both sides. Just cancel out. So 5 divided by 0.643 equals 7.776. So this is 7.776. That's the hypotenuse. Done. What's the length of DE? DE. Let's just call it x. Here's your 50-degree angle. Right? 50-degree angle. You go to 50. We're looking for opposite. Remember, it doesn't touch. This is hypotenuse because it's across from the 90, meaning this is adjacent. So the adjacent leg does touch. This leg does not. So you use the one you're trying to solve and the one that you're given. So op over adjacent for 50 degrees equals op over adjacent for 50 degrees equals 1.192. Now you just plug them in. Op over adjacent, x over 6 equals 1.192. Put a 1 over there. Cross multiply. X times 1 is x. 6 times 1.192 is 7.152. X equals 7.152. X equals DE. So D equals 7.152. That's how you do these. Okay, I gotta go sub. See ya.